Hi everybody, welcome to day 3 of chapter 2 and 3. Today we're going to look at properties of linear functions and other forms of linear functions. So we're going to be doing some graphing, we're going to talk slopes, and we'll talk about writing equations of lines. Alright, so to begin with, we're going to focus on slopes. So we're first going to talk about what a positive slope is, negative slope, zero slope, undefined slope. So what do you remember about those? Okay, so what does a line with a positive slope look like? Well, hopefully you remember it is going to look something like this, where it rises from left to right. A negative slope is something that is going to start top left and go towards the bottom right. So this is going to be a line with a negative slope. What is a zero slope? What kind of line is that? Well, hopefully we recognize or we remember that a zero slope is a horizontal line. There's no rise, but there's an infinite run. And so an undefined slope is going to look something like this. Okay, so what is our slope formula? Okay, and then we'll kind of go back and talk about that zero slope and the undefined slope there. All right, so hopefully we remember slope is our rise over our run. Another way we can think about it is our change in y. Sometimes we use that notation, that little triangle there represents change in over our change in x. And then that gets us to our actual formula, where we talk about y2 minus y1 all over x2 minus x1. So there's our slope formula. So let's kind of go back to this zero slope and this undefined slope, okay? And what is our slope going to actually be? Well, if it's a zero slope, like I said before, that means we have no rise, so that means our numerator is going to be 0, okay? So we might have something that looks like where our m is going to be 0 over some number, any number, all right? So when we have 0 in the numerator and some number in the denominator, we just get 0, okay? So that goes along with our zero slope. Now, if we have an undefined slope, when do we have something that's undefined in math? Well, we have to think about a ratio, right? So we're thinking again, rise over run. What makes something undefined? When our denominator is 0. So an undefined slope might look something similar to this. When we're calculating, we might get some number over 0. We don't call that 0. We don't leave it as 12 over 0. We state that this is undefined. Okay, so that's really important. So make sure you understand that concept. Okay, let's move on and actually calculate the slope of the line containing those 2 points. So this is just where we are plugging into our slope formula. So hopefully this doesn't take too long and we are all comfortable doing so. So we can call this our x1 and our y1 values, and we can call this our x2 and our y2 values. So quick refresher there. So if we're calculating our slope, we get m is equal to our y2, -4, minus our y1. Notice how I'm using parentheses because we're subtracting a negative, so we have to remember to change our sign there. And that's divided by the change in x, which is x2 minus our x1. And again, I'm using parentheses. So just showing those steps, this really becomes -4 plus 1 over 3 plus 2, and we get our final answer of -3 over 5 for our slope. Okay, other key vocabulary that we're going to talk about very often is our x and our y intercepts. Okay, so just a quick refresher, what is a y-intercept? Graphically speaking, it's where our graph crosses the y-axis. Okay, so thinking about our axes, if I kind of draw this over here, we have our x-axis and our y-axis. We want to know, all right, well, where does the graph cross our y-axis? It would be at this point here, correct? So what's our x value there? Well, it's when x is 0, right? So it's where it crosses the y-axis, and it's when our x value is 0. So we can think of it as an ordered pair, some value where x is 0, and we get some y value. Similarly, for our x-intercept, we want to think about where the graph crosses the x-axis. So again, if we're looking at our example over on the right here, graphically, we're looking at this point right here that I just circled in orange. So what's our y value at that point? It's when our y value equals 0. So we're looking at the point some x value, comma 0. Now we're going to get into graphing. Okay, so we're going to do a quick refresher of the 3 different forms of lines that we're going to look at, and then we'll graph each of those, and I'll talk about the expectations that we need to show. All right, so our first one is probably the one that we are most familiar with and most comfortable with, and that's our slope-intercept form. So our slope-intercept form is in the form y equals, and then we have our slope m x plus b. Okay, m is our slope, and what's b? Hopefully you remember b is our y-intercept. Okay, when we are graphing from slope-intercept form, you need to show and label 3 points on your graph. Okay, now if you remember, we always start by graphing the y-intercept, okay, if we can, and then we use our slope to count up and over or down and over to get 3 other points. Okay, so what we should recognize is in this first example, y equals 4/3 x minus 2. -2 is our y-intercept. Okay, so we can think of it as the point 0, -2. And we could go ahead and plot that. So that's down here. And now we have our slope, which is 4/3. So m is 4/3. So now we're just going to count up and over. Okay, now remember, our slope is positive, so picture what that line should look like. All right, so now again, I'm just going to label this on my graph. That's the point 0, -2. And now I'm going to use my slope to count up 4 units and to the right 3 units, since it is a positive slope. So I count up 1, 2, 3, 4 over 3. 1, 2, 3, and it puts me at the point 3, 2. So I'll go ahead and put a point there. And if I'm still able to, I can count up 4 and over 3 again. So by doing so, I'm 1, 2, 3, 4 over 3, 1, 2, 3. I plot my point over there. All right, and then we go ahead and we draw our line through this as best we can. And I'm going to go through and label those points as well. So this is the point 3, 2, and this is the point 6, 6. The next form is point slope form. In terms of graphing point slope form, it's very similar to slope intercept. It's just we're not necessarily plotting our y-intercept. So if we can remember that form, it's going to be in the form y minus, and then we're going to have this point y1 equals m times a point comma, x minus x1. Okay, so our slope is still m, and then we have a point that is x1, y1. Okay, so instead of the point 0 some y value, we just have a different point, and we are still requiring 3 points on your graph labeled. Okay, so the first thing when we are graphing out of point slope form is rule number 1, we never change forms when we're graphing. We need to be able to graph out of all the forms. Okay, so when I see point slope form, first thing I want to do is I want to identify the point, and if we see here, we should be able to see that our point is going to be, our x value is going to be 1, but what's our y value going to be? Notice that this is a plus here, but our form has a minus. So that means our y value is going to be the opposite of 2. So it's going to be -2. All right? And then if we identify our slope is still -5 halves. So note, it is a negative slope. What should that line look like? All right, I'm going to start by plotting my point 1, -2. So that's going to get me here. And now this time, if I count up 5 units, I need to count to the left 2 units. So going up 5 units, 1, 2, 3, 4, 5, and to the left 2, it's going to put me at the point -1, 3. Okay, oh, and my starting point was 1, -2. Okay, I need one more point. I need 3 points. So if I count up 5, 1, 2, 3, 4, 5, that works. I'm still on my grid. I can count over 2. So that's going to put me at the point -3 and 8. Okay. If I ever get off of the grid, I might have to rescale my axes. All right, and we can talk about that. Now I go ahead and I draw my line, and we just plotted a line out of point slope form. The last form we're going to talk about is standard form. Now this is kind of a special case when we're graphing. We only need to graph 2 points. So our standard form of an equation, it's not really straightforward what the slope is or what another point is without doing some manipulation. So our standard form is in the form ax plus by equals some constant c. Okay? Now, when you're graphing out of standard form, we are okay if you just plot 2 points. But what are those 2 points going to be? The intercepts. Okay, so the x and y intercepts are what we are going to plot. Now, it's kind of hard to show this on the video itself, but we sometimes use the term pinky method to find our intercepts. So we essentially take our pinky, and to find the y-intercept, we cover up the ax with our pinky. So I pretend that this piece is gone, and I'm simply solving the equation by equals c. I'm solving for what c is, or sorry, for what y is. So our x value is 0, and if I were to get y by itself, I would just have to divide both sides by b, so I would get c over b. And then to figure out the x-intercept, I do something similarly, only this time our y value is 0. So now I'm going to cover up this piece with my pinky, and I'm simply solving the equation ax equals c. So I have to divide both sides by a in order to get my x value. So I get c divided by a as my a value. Okay? So if we're looking at this first example here of 2x minus 3y equals 12, I notice this is in standard form, so I just need to identify my two intercepts, plot those points, and I am done, okay? I'm not going to change this to slope-intercept form, okay? So our y-intercept is when x is 0. So I'm really just focusing on the equation negative 3y equals 12. If I divide both sides by negative 3, 12 divided by negative 3, I get my y value to be negative 4. Our x-intercept, again, is when y is 0. So now I'm going to cover up that minus 3y portion, and I'm solving 2x equals 12. Dividing both sides by 2, I get our x value to be 6. So now all I have to do is plot those 2 points, and then I can draw my line. So here's the point 0, negative 4. And here's my point 6, 0. And I can draw my line through these 2 points, and we're good to go. The next 2 lines are going to be horizontal and vertical lines, and we kind of already talked about this when we talked about the slopes, but the equation of a horizontal line is simply y equals some constant c, okay? And we'll show you what that looks like. A vertical line is where the x values stay constant, right? So it's going to be x equals some constant c. So if I'm looking at this first equation for a horizontal line, and I want to graph y equals negative 3, that means no matter where I am on my line, the y value is negative 3. X is changing, but y is not. So I can simply go down to a few points where y is negative 3, and I can connect these, and we have our horizontal line at y equals negative 3. Sure, we can go ahead and label some points. So we have 0, negative 3, I think that's 3, negative 3, and then that looks like negative 4, negative 3. So our y values stay the same, our x values are changing. Similarly for vertical lines, now x is staying the same and y is changing. So I can pick any point where our x value is 1. So here's when x is 1, up here x is 1, and down here. And I could go ahead and draw a vertical line right through it. And if we label those points, I have the point 1, 4, 1, 0, and 1, negative 3. The last thing we'll talk about is writing an equation of a line. Okay, now the rule of thumb is we want to pick the best form. Writing an equation in standard form, probably not going to happen. Your 2 choices will be slope-intercept or point-slope. Okay, we never convert to slope-intercept unless we need to. All right, we'll talk about that more later on. So the first thing I have to identify is what information do I have? Okay. So we want to write an equation of the line that contains 4, negative 2 and has a slope of negative 3/8. So I ask myself first, is this line the y-intercept? Okay. And hopefully you can say no right away, right? Because is our x value 0? No. So it's not our y-intercept, okay? Not our y-intercept. All right, so it's just a point, okay? It's just a point. So now let's look at our slope, right? We were given our slope. Okay, so we have our slope. We don't need to figure that out. That's easy enough for us. So if we don't have our y-intercept, we have some other point, and we have our slope, what's the best form of the line to choose? Hopefully you're able to say point-slope. Okay, so point-slope form, remember y minus y1 equals m times x minus x1. And now let's plug in. So we have y minus, well, what's our y value? Hopefully we see it's minus 2. So I'm actually going to change that to a y plus 2 equals, what's our slope? Well, we were told our slope is negative 3/8 times the quantity x minus 4. And we leave our answer just like this. No need to manipulate it. We are good to go. If you have questions, come to class with those next time we see each other. Bye-bye.